Okay, 2 o'clock. All right, welcome to the 2025 Elakha Alliance Virtual Science Symposium. We're happy to have you today, and we are on our final presentation of the day. First, I just want to talk about who we are hosting this. We are part of the Elakha Alliance, which is a nonprofit based in Oregon, and our mission is to make Oregon's marine and coastal ecosystems and communities more robust and resilient by restoring a healthy population of sea otters back to the Oregon coast. So we're excited to bring a lot of scientists and researchers together for this symposium to talk about the latest updates of sea otter conservation. And so our final presentation today is with Dr. Shawn Larson, who is doing amazing and juggling multiple presentations today, and also really helped me behind the scenes to get this symposium together. So personally, thank you very much, Shawn, for your help. And so let's dive into envisioning sea otter recovery in the 21st century.
Okay, thanks, Chanel. And thank you so much for the Elakha Alliance for organizing this symposium. And all of the talks have been great so far. Learned a lot, and it's a lot of information to absorb. So here we are in the final stretch. Just a little bit more information to share with you. Let me share my screen. And hold on, now I got to start it. Okay. Look good, Chanel?
Yep.
Okay, great. Okay, I want to start off. So I'm going to talk about, moving this bar over here. I'm going to talk about chapter 12, which is envisioning sea otter recovery in the 21st century, and kind of wrapping up the book. But first, I want to talk about the first volume, Sea Otter Conservation, versus the second volume. So Sea Otter Conservation, Jim already touched on this a little bit, was published in 2015. It was what was known about sea otter biology and ecology at the time. It's still very relevant. It had 19 contributors, authors and co-authors of the chapters in that book. It's about 400 pages. Fast forward 10 years later to Sea Otter Conservation Volume 2. It has almost twice the number of contributors, 36 authors and co-authors. And it really focuses on the nuances of sea otter recovery and what we've learned from the fur trade, especially the first part of the book. And then the following parts of the book are more into what drives sea otter recovery, monitoring, genetics, the Elakha Alliance, etc. So we have more contributors in this second volume than the first. And we also encouraged early career authors to participate. And for example, chapter 8 is led by Dr. Jessica Hale, who, when we started this adventure, had just gotten her PhD. That was 3 years ago. So writing these books does take some time, and it's a lot of time, dedication, editing, etc. And I just want to thank all the contributors and all of the people that have spoken today. I think that's all I had to say on that. Moving forward, why isn't this going? There we go. So really, this book was about recovery from the maritime fur trade and where sea otters are at. And you can see here on the bottom, this is the IUCN, or International Union for the Conservation of Nature, red list of sea otters, and it was last assessed as endangered in 2020. And that is because of declining populations in the Aleutians, Russia, and elsewhere. And then more recently, it was, and just in context, the red list is assessment of the species risk of extinction. So they are endangered worldwide, but they are recovering. And that is what the green status assessment is. And you can see here, this was recently done this year by myself and Riley Pollum. And this is an assessment of the species conservation potential. And so this is how conservation efforts can actually recover species. And even though they are largely depleted still, because they're about 50% recovered, sea otters actually have amazing conservation potential. And the reason why they are still endangered and largely depleted is the absolute numbers remain uncertain. There's large, very remote areas that are hard to survey regularly, certainly not annually. The Aleutian Chain and out in Russia and the Kuril Islands are not surveyed annually for sure. And so those absolute numbers, it's usually once about on average every 10 years or so. So we're not really sure how many otters are in those systems. Plus, they're hard to count because when they're being surveyed, some of the otters are underwater, some of them are on the surface, et cetera. So there is some error biases in those monitoring methods, of which is covered in chapter 7 of our book. And we think that sea otters, as I mentioned in my last talk, aren't occupying all the ecosystems in which they had previously occupied. So their distribution and the ecosystems in which they occupy are not complete. And that's one of the reasons why we state that they are about 50% recovered. And here is a map of sea otters today. And what you can see is sea otters do occupy much of their original range, but there are areas where sea otters are still absent. The sea otters are absent from Haida Gwaii, for a large portion of Haida Gwaii. And then there's this big section from central Washington to central California where sea otters are still absent. You might ask what these different colors are. The brown colors are sea otters that have recovered from remnant populations that were left after the fur trade. And the yellow highlighted areas are areas that recovered due to translocations. So pre-fur trade estimates are that before the fur trade, there are about 300,000 sea otters in the world. Today, or recently, the last best estimates that we have is that there are about 120,000 sea otters in the world today. And again, these numbers are estimates. We have no way of doing a complete census on sea otters. So whenever we're going out there, we're just surveying and getting an estimate of the number of animals that are actually in the population. So recovery has been fueled by abundant food and space left over after the fur trade. Jim touched on this. I touched on it a little bit. Basically, where sea otters were left after the fur trade, they were able to recover relatively quickly because of abundant food resources, habitats that were left intact. So the recovery has been a process of sea otters being absent, then present, then increasing in abundance. And sometimes after they increase in abundance, they decrease in abundance. And at some point, they're going to reach equilibrium. There's been range expansion as they approach equilibrium in some areas, and there's been contraction. And then a lot of people ask, in fact, there was a question in the last presentation, what is equilibrium? Well, it changes based on the environment. So we used to think that sea otters were at equilibrium density, for example, off of Monterey Bay. But after the sea star wasting event, that removed that mesopredator, and it offered up a lot more urchins that recovered, rebounded, and then there were more food for sea otters, so then that equilibrium density shifted. And so equilibrium is going to change over time with a changing environment. Lessons learned, and we've talked about this many times throughout the day, is that we know sea otters are a keystone species. And what does that mean? I love this graphic, is that that keystone is just that stone in the arch that holds the whole system together. And we've seen it time and time again. Where there's sea otters, there tends to be more benthic kelp communities, also stable eelgrass, stable salt marshes. And without sea otters, we have this monoculture or urchin barrens. Now, this doesn't hold up every time, as Matt said in his presentation, and then have we seen in Southern California versus what happens in Northern California, the ecosystems are complex, and there's different processes that come into play based on exactly where you are. So we're not done monitoring sea otters' effect on the ecosystem. I think in every area there's going to be slightly different effects, and we need to do diligence and good science to study what's happening in the benthos and areas with sea otters versus areas without sea otters while the sea otters are recovering. So yeah, the lessons learned: the state of sea otter recovery and restoration of coastal ecosystems are connected and complex. We have the example in the eelgrass where the sea otters eat the crabs that then free up the grazers to graze the eelgrass so they can photosynthesize easier. We have the classic sea otter urchin kelp forest trophic cascade, and then we have the salt marsh cascade where the sea otters eat the crabs and freeing up the salt marsh from erosion. All these things are dynamic and changing over time. As sea otters reoccupy, the system changes from initial recovery, where you get rebound of the high kelps, to then restabilizing to a lower level, but higher than before it was without sea otters. And we saw this again before, that over time, even those species that sea otters eat will recover and become more abundant, maybe not necessarily within the sea otters' diving depth, but just adjacent. And they're going to be in more cryptic areas and uh, crevices where they are protected from sea otter predation. And then also we do see an increase in finfish areas once sea otters recover the ecosystem. And then their diet changes over time. Showed this again previously. When sea otters first move into an area, they tend to consume the animals that are their preferred prey. But over time, as they occupy, they have to diversify their diet. And then this also does change the ecosystem as well. Lessons learned: besides their status as a keystone species, we've learned that translocations work. And this is just showing you how far in North America sea otters were moved to recover populations where they were still absent from the fur trade. So many sea otters were moved from Amchitka Island over here in the Western Aleutians to Southeast Alaska, to Vancouver Island, and to Washington State. And then also sea otters were moved from Prince William Sound to Southeast Alaska and to Vancouver Island, but not to Washington State. Sea otters were also moved from Amchitka to the Oregon coast, but that translocation did not take. And it's thought perhaps that some of those sea otters in Oregon swam north, and once they ran into the otters that were in Washington, since both of those populations were founded only from Amchitka, they might have recognized their cousins or their relatives and said, "Oh, here I am. I will just stay here." So we're not really sure because those animals weren't tagged and tracked, but that's what we think may have happened to some of the otters that were translocated into Oregon. Again, here's this area, this large area where those translocations have recovered sea otters, where they were hunted to extinction during the fur trade. And then we also have this little translocated population off of Southern California that was taken from Monterey and moved to San Nicolas Island. So altogether, those translocated sea otter populations account for about 30% of the sea otters alive today. So sea otters are one of those species that can be easily recovered if in successful translocation efforts. But it takes time. It takes decades. And I have experience of monitoring the sea otters off of the Washington coast. And I started monitoring them in the early 2000s. And this was 30 years post the translocation effort. And there were only a couple hundred sea otters off of Washington at that time. But fast forward 25 years from that time, and now we have almost 3,000 sea otters off of the Washington coast. But it's not the growth of the translocated populations are slow initially, and it takes time. But keep in mind that all the previous translocations, there were only one or two translocation efforts. So we don't know what might happen in the future if there's a more consistent translocation effort over many decades, or I'm sorry, and over many years. Lessons learned: recovery is not stable. So ecosystems are still equilibrating, and will continue to change over time. So these are this is the figure that we've seen a few times today from Estes et al. 1998 paper, where sea otters were thought to be recovered in the Aleutian Islands, 100% equilibrium. And then the orcas started to change their diet, started to eat the sea otters, and they dramatically decreased over 90% depletion. And this is happening right now also off of Russia and in the Kuril Islands based on the most recent surveys done there. And then I mentioned earlier that great white sharks also will indirectly negatively affect sea otter range expansion and population growth because they mistake them for their preferred prey, which are seals and sea lions, as otters are resting on the surface. But by the time they realize their mistake, that otter is essentially dead. So that's what we've learned in the past. And a lot of those systems will continue into the future. So what do we expect for sea otter recovery into the 21st century and beyond? Well, there's likely to be continued predations as ecosystems equilibrate and recover, as other predators and apex predators recover, like sharks, like orcas, like eagles, like bears, like wolves. There may be changes also in sea otter protections. We're not really sure about, for example, our federal laws, how stable they are. There's impact from pollution, negative impact from pollution, primarily from marine debris. And then there are the unknown effects of climate change. So I'm going to touch on each of those briefly. Again, predations, I just talked about that. We've just started to observe in the last few decades, brown bears predating on sea otters, wolves, and the effects from eagles. So there's a lot of data being collected on these predations and the potential effects on sea otter population growth that's happening in Alaska, and a lot of new work being done by researchers, by the National Park Service, USGS, and others, as well as PhD students. So all those lessons learned will come into Sea Otter Conservation Volume 2 in the future. And then, Volume 3, sorry. And then what about protections? Like I said, national protections with the Marine Mammal Protection Act, of which all sea otter populations in the United States are currently protected. We're not sure if that will remain intact, hopefully. What's going to happen to the Endangered Species Act? Right now, there are 2 populations of sea otters that are protected as threatened under the Endangered Species Act, and that is all of the southern sea otter off of California, and that is the western stock of the northern sea otter, basically from the Alaska Peninsula throughout the Aleutian chain. So we're not sure what's going to happen to those protections. I imagine CITES and IUCN, the international protection. So CITES is the Convention for the International Trade of Endangered Species, will continue, and sea otter trade is limited under CITES. And also the International Union for the Conservation of Nature. I showed that at the beginning of this talk. Sea otters are listed as endangered on the red list and largely depleted on the green status. Those will afford international protections and have been used for international protections, specifically to inform CITES. But again, international protections requires enforcement. And then we're not sure to the extent of future take. Alaska Natives, again, with an exemption under the Marine Mammal Protection Act, are allowed to take sea otters to reestablish their cultural connection with sea otters. So they're reconnecting with the sea otter through excluding them in certain areas for food security, but also to relearn how to use their pelts. And we're not sure what's that is going to do to the local populations of sea otters in Alaska. Right now, the harvest has definitely been sustainable. In the future, may change. That's a future discussion to be had. What about pollution? Sea otters are vulnerable to oil spills. The Exxon Valdez oil spill in Prince William Sound devastated sea otter populations. Thousands of sea otters were killed. We don't really know the absolute numbers because not every sea otter was picked up, but sea otters are definitely vulnerable to oil spills because of they need their intact fur to maintain thermal regulations. And when they get oiled, they can't clean their fur, and also they ingest all that oil, and that's a lethal combination for a sea otter. Um, Almost every sea otter population in the United States has oil tankers going past them or close by. So they're definitely vulnerable, particularly in California and off the coast of Washington, where there's major oil shipping lanes right by the sea otter population, feeding both Washington as well as British Columbia. And then there's the unknown about marine debris. There's certainly been a fair number of pictures with sea otters with trash on their chests that they bring up from the benthos. There's probably sea otters that have been entangled in marine debris, and there's an unknown effect from sea otters ingesting microplastics. They eat a lot, up to 25–30% of their body weight per day. They're ingesting, and they're eating mostly filter feeders, which are concentrating microplastics. So this is an area that we're not sure how that's negatively affecting the health of the individual sea otter. Harmful algal blooms will, again, they will concentrate that toxic algae into the filter feeding prey, and can negatively affect sea otters for sure. And then there's the nearshore runoff, which tends to take terrestrial diseases, viruses, bacteria, protozoans, everything, and bring it into the nearshore. And then it's concentrated again into those filter feeding prey of the sea otters, and have been known to impact sea otters and increase disease events. All of these are going to continue in the future. Thus far, some sea otter populations have been negatively affected by pollution and marine debris and diseases, and then others not so much so. So more work needs to be done to determine how that will affect sea otter recovery in the future. And then there's climate change. So this is the big one that we have a lot of unknowns around. So increasing sea surface temperature, how is that going to affect sea otters' ability to live in some areas when the ocean may become too warm for them? Increasing sea levels as the ice sheets melt, increasing ice-free areas, and then there with increased ocean acidification, decreasing calcium carbonate shell making by their prey. And you can see here an otter's eating a nice big clam, and what's going to happen if there aren't so many clams to be eaten by the sea otters. So I'll touch base on those really briefly. Again, this is a lot of unknowns that we're just starting to think about, really, and this is future growth for future sea otter researchers to look into. So this is a map that was created for the green status assessment. And what it shows is the areas where sea otters are absent. This is that used to be, and that's the red areas. And where sea otters are present, so in lower numbers, light green areas, where sea otter populations are doing well in the dark green. And then you see this gray area, and that is where sea otters might expand their range with climate change. So these may become 100% ice-free areas year-round, and so that would allow sea otters to live to the north in the Bering Sea. We don't know how far north they'll go, but sea otters have to eat every day. So with seasonal ice sheets, that would preclude them from diving in their preferred diving depths, they can't live in those areas year-round. But if those areas are ice-free year-round, then sea otters might be able to expand their range into these areas. They may also, if the waters get too warm, they may not occur in these most southern areas. They may have to move north. We're not really sure. Again, this is a big unknown moving into the future. So what happens if the North Pole is ice-free? Well, sea otters might actually move into the North Atlantic with unknown ecological consequences. And about 1 million years ago, it's thought that sea otters actually did move from the Atlantic Ocean, where where fossil records suggest they evolved about 6 to 7 million years ago from old world otters. So their closest relatives are those otters in Africa. And it's thought that about 1 million years ago, they moved through ice-free areas of the North Pole to establish themselves in the North Pacific. And then they later became extinct or absent in the North Atlantic. But the reverse might happen with ice-free areas in the North Pole. Again, this is probably, hopefully, a long time in the future, and we're not really sure, but it's interesting to think about sea otters being in the Atlantic again and having and learning all those new ecosystem interactions like we have learned in the Pacific where sea otters have recovered. There may be a decrease in their prey items, particularly those that use calcium carbonate shells, which is majority of their shelled or all of their shelled prey. So crabs, clams, urchins, mussels. But sea otters already eat things that don't make calcium carbonate shells. So for example, sea otters already eat cephalopods. I personally observed, and I know many of my colleagues have observed sea otters eating giant Pacific octopuses and squid at times. Sometimes they eat fish and sea cucumbers. I know they eat cucumbers, and I have seen sea otters eat large gunnels off the Washington coast. And I know sea otters have been known to eat lumpfish in the Aleutian chain when there's a big lumpfish spawn. So sea otters can eat fish. But is this enough? Is this enough if there's a dramatic crash in their calcium carbonate shell-making prey items? Will this be enough to supplement sea otters again? We don't know. The future is hard to determine. And also, what will the consequences be for the ecosystem? It would lead to a breakdown of our known trophic cascades, but perhaps if they shift to these cephalopods and other non-calcium carbonate making prey, maybe there will be new trophic cascades to be discovered, again, to be determined. So climate change will affect sea otters. We don't know at what level because we don't know how dramatic it's going to be in the North Pacific where sea otters live. But what role do sea otters play in climate change? Rasher et al. 2020 suggested that keystone predators, specifically sea otters, may impact climate change in the Aleutian chain. Specifically, they found that the urchins were dramatically reducing the reef-building algae, the clathomorphum algae, in warming waters and more acidic waters. And they hypothesized that at areas with sea otters, the sea otters would control the urchins. And so even though the oceans warmed and were more acidic, the urchins wouldn't decrease the reef-making algae as dramatically. So Rasher et al. Was really one of the first ones to suggest, can sea otters stabilize kelp ecosystems and mediate the negative effects of climate change? Well, I actually have some benthic data that I think can point to this. I have a very limited data set on the western Strait of Strait of Juan de Fuca near Nia Bay. And what it just shows you here is that after the blob, which Bob mentioned, the 2015 warm ocean event, what we saw in 4 sites was a decrease in fleshy algae cover over after 2015. And this corresponded with a dramatic increase in urchins in those areas. So we saw a decrease in understory algae and canopy forming kelps and an increase in urchins. So that's this classic ecological shift from kelp forests and algae dominated ecosystem flipping over to an urchin barren. We saw that in all sites, all of our dive sites, except for one, except for this site 5. So what's different with site 5? Well, you'll see here site 5. I hope you can see my pointer. Here, I'll do this.
I can see it.
All right, here you go. So site 5, here's site 5, and all these orange circles are sea otter occurrence and density given to us by our partners with the Makah tribe. And so they do regular sea otter or marine mammal surveys in this area, and they've been noting sea otters Site 5 has over 10 otters per kilometer here. And this is our site that stayed stable. And here's our dive sites 1 through 4. And you can see there are definitely otters nearby, but they're not at ecological density. And so here's what site 1 looked like before the blob, before sea star wasting. You can see there's just a lot of sponges. You can see there's a couple pycnopodias here. You can see it's got a lot of understory algae, etc. Fast forward 2018, it's scoured clean. And what you can't see in this picture, well, you can see there's an urchin, there's an urchin. There's tons of urchins in this ecosystem. But here's site 5, 2011. You just see lots of algae, lots of sponges. And fast forward to 2023, this is a picture that was taken by our ROV that's starting to take hundreds and hundreds and hundreds of photos in these areas to really understand what's happening in areas with sea otters versus those without. And the ocean warmed, the sea stars wasted, but site 5 benthically did not change at all. The community structure remained exactly the same. And we think it's because of this ecological functioning density of sea otters that's consistently around site 5. So we suggest that this is more evidence that sea otters can help mitigate the effects of climate change. And this is just a beautiful, this is a raft of what I thought was kelp, but when I zoomed in with my scope, and this is video through the scope, these are sea otters, and this is an area in central Washington. It's really south central Washington of about a raft of 700 sea otters. So this is an example of a sea otter population in transition, in recovery, and it's gotten past that slow growth rate point, and it's gotten to this higher growth rate point, and their large rafts of sea otters are forming. And this raft was consistently there for a number of years and still can be seen occasionally. And it just shows you the productivity of the outer Washington coast to be able to support a number of otters this large. And I know this is, it's a mixed rocky system, but this is right adjacent to large areas in Washington, which are the soft sediment, unconsolidated habitat that Jim talked about, where really there's supports large numbers of sea otters. And this is what we're seeing in Washington is the majority of otters in Washington now live in these soft sediment habitats. Getting back to Sea Otter Conservation Volume 1, this took about 3 to 4 years to create and really set the foundation for Sea Otter Conservation Volume 2. So this was just the baseline. This is what we know at that time about sea otter biology, ecology, and then that afforded us the ability to really think, well, what have we learned since then? And it's been a great journey to see how much we've learned since then as sea otters recover in different ecosystems, in kelp forests, in eelgrass, in salt marshes, and just to show that the systems are different and dynamic based on where they are. And you saw that in Aaron's talk, you saw that in Matt's talk, and there's just so much that we still have yet to learn as sea otters continue their journey towards recovery. And I'm really excited about what we will learn will happen in Oregon. And I would suggest it's probably very similar to what's happening in Washington because the nearshore habitats are very similar. And with that, I'll take questions.
Super.
Okay.
Thanks for
Stop
a
sharing.
great inspirational end to the symposium. We do have several questions for you.
Okay.
So when did sea otters become northern and southern sea otters? Is it more than size?
So as Bob eloquently said, a sea otter is a sea otter, and what we think, the sea otter subspecies were named by Wilson et al. In 1991 based on skull morphometrics. There had been a lot of discussion before then about, pelt, color and size, etc. And we think that sea otters observe wide-ranging species typically do this is clinal variation. So as they move to the north, they tend to get bigger, and then as move to the south, they tend to get smaller. But and Jim can, if he's still there, can correct me if I'm wrong. So sea otters, southern sea otters generally are smaller than northern sea otters, but I would suggest that it's not necessarily a genetic difference, but it may be related to food availability because when they did the translocation from Monterey to San Nicolas, the next generations of sea otters, which had plenty of prey, were bigger than your typical southern sea otter. Is that true, Jim?
Yeah, that's true, Sean. I think I agree that it's a clinal variation effect that it has been exaggerated by the 100 years of separation created by the fur trade.
Yeah.
They're just no
And
longer able to, yeah.
Yeah, thank you for that. And to Jim's point, southern sea otters and northern sea otters definitely have genetic differences that we see today. But I think that part of that is exaggerated by the fur trade and the fact that southern sea otters have been isolated genetically from all other sea otter populations for over 150 years.
So, Sean, this is Bob. I would
Yeah.
also say that the southern sea otters have been enshrined into a sort of a special status as a subspecies through the Endangered Species Act. You know, it's that I think that has further helped to draw a line around that species as a subspecies.
Yes, like I mentioned, all sea otters are afforded protection by the Marine Mammal Protection Act, but then there are the southern sea otters that are further protected as being listed as threatened under the Endangered Species Act, as well as that southwestern stock of the northern sea otter.
Right.
So it's to me, I mean, it depends on if you're a lumper or a splitter. I tend to be, this is in taxonomy terms, I tend to be a lumper. I think that sea otters used to interbreed, and we think there's evidence that Oregon was a transition zone between southern sea otters and northern sea otters, and we want to reestablish that genetic connectivity. And subspecies is really a human construct that we put around things to better understand differences. And really a subspecies, the last definition I looked up, and it's been a while, a subspecies should be a group that is in the process of becoming a new species and is really isolated from other populations. And I don't think that southern sea otters are currently going to become a different species.
Awesome. Thank you,
Thanks for
everyone,
that question.
yeah. Um, okay, another question for you. Is the Alaska native take of otters well regulated? Is this management a model or cautionary tale for other areas and populations?
I don't think I'm qualified to answer that. I don't know if Bob or Jim are.
I'll say, yeah, I can. The harvest is isolated, and in most places, it's probably at a sustainable level, and at other places, it's probably beyond a sustainable level. So it's not managed uniformly across the strait. It's across the state. It's very much managed at local levels, and they're not all equitable.
Got it. Thank you, Jim. What can we do to help mitigate the threats discussed to sea otters? Asks Ashley.
That's a great question. And to Jim's point, sea otter recovery was really possible because of intact habitats. And so I think that's what people can do is they can help protect sea otter habitat that has been previously occupied and hopefully will be occupied in the future. So this is really about nearshore ocean conservation. So less pollution, overharvest of species, restoration effects if there have been disturbed areas. Yeah, clean water, plenty of prey is what sea otters need, and then they will work their ecosystem magic. But they need intact ecosystems that can provide them adequate food and other resources to thrive.
Great. Alexa is wondering, what research are you currently working on, and is there a way to support as a Washingtonian?
I love that question. Yeah, so I mentioned that we have some very exciting benthic information that suggests to us that in this little region off the near the northwest tip of Washington, that sea otters have stabilized the benthic system after the last marine heat wave or blob, after sea star wasting, all of that. What we need is more of that data. And so I do have a coastal climate resilience scientist at the Seattle Aquarium, Dr. Zachary Randell, who did his PhD on the effects of sea otters around San Nicolas Island. So he's very familiar to monitoring the benthos in areas with sea otters and without sea otters. And he's been doing work on what stabilizes bulk kelp forests in Puget Sound. And I want to take that work, that foundational work that he's been working on, and put it into the outer coast to get much more data of what I just shared with you, because I only had 5 sites. I didn't have replication in that one sea otter site. And as my first talk was Tim's talk was all about replication. Good science is based on replication, where we need to replicate that over and over and over again on the outer coast of Washington to really understand what's happening, and the patchy distribution of kelp out there with sea otters at equilibrium density, and with sea otters that are growing and may not be at the density for ecosystem functioning. So this is work that we want to launch. I'm hesitant to say contribute to the Seattle Aquarium, but we're actually looking to the Sea Otter Fund to help us launch that range-wide ROV paired with diver work to really get a handle on what's happening on the outer coast of Washington, to see how sea otters are mitigating the effects of climate change. And we hope that what we learn from that will help inform what's going to happen on the Oregon coast, and then be an even greater driver for newer reintroductions into Oregon. So I guess I would say give to the Sea Otter Fund, or to other organizations like Elakha Alliance that are promoting the recovery of sea otters.
Yeah, I can put a link to so the Wildlife Conservation Network is a group that created the Sea Otter Fund, and so they are privately getting donors to help contribute to sea otter conservation work across in the United States, basically. So
the aquarium will also take donations, but I feel
yeah, no, go for
weird
it.
saying that.
Don't feel weird at all. We support you guys too.
Yeah.
All right. Is Russia currently doing anything to help preserve sea otter populations near Alaska?
I know there are Russian researchers. There are fewer than there used to be. The community used to hold a Russian U.S. sea otter workshop regularly, that broke down many years ago. So there still are Russian researchers, and Jim, again, I'll point to Jim if he knows more than I do. Recently, we got a survey of what's happening in the Kamchatka Peninsula, the Commander Islands, and the Kurils, and that's where it was suggested that sea otters are declining in that area by about 70%. So they are continuing to Russian scientists are continuing to do surveys, but I'm not sure about national protections that are in place for sea otters. Jim, do you know?
Yeah. Sea otters in Russia have complete protection from human harvest. They did have a small scientific harvest. I don't know if that's ongoing, but they're completely protected from human harvest throughout Russia.